Welcome, everyone. Thanks for joining us again for Mass Timber March Madness. Presenting next will be Fabian Scheurer of Design to Production. Really looking forward to this. He's done so many amazing projects. Before we begin, I want to again thank the U.S. Forest Service and the Tallwood Design Institute for supporting this event. Fabian, please, I'll let you introduce yourself because I can't begin to cover the depth you're in.
I'll try to do as short as possible. Thank you, Greg. Thanks for the invitation. Thanks for organizing all this. Hello to everyone, wherever you are. As Greg said, my name is Fabian Scheurer. I'm one of the founders of Design to Production. Actually working in the timber business more or less for the past 15 years. I just have to find the right screen to click on. There we are. So, little introduction on Design to Production. Design to Production actually is a spin-off of the ETH in Zurich, a technical university where I used to study many years ago. We founded that as sort of a research group inside ETH, and then since 2007, we are a company here in Switzerland with another office in Germany. What we're doing is actually pretty much defined by the name. We're doing neither design nor are we doing any production, except for a small 3D printer that's over there in the corner. We're just doing the two in the middle. That means we're helping to translate design into production. And we're informing design about production. So we're also trying to get the knowledge forward and upstream, because I think that's very important for the things we're doing. We claim that we would speak both design and production. So the ideal is to simultaneously translate between designers and fabricators, and do this both personally, but also put this on a digital basis. So this is about digital design and it's about digital production, digital fabrication. And we realized 15 years ago that there's quite a gap between the two. Everyone that has ever tried to print something on a small 3D printer knows that it's not as easy as the vendors tell you, that you just put a 3D model on a USB stick, carry it over, plug it in and press the button. And if you scaled it up a couple of numbers for real time and real size projects, it's not becoming any easier actually. So what we do is we place ourselves deliberately between all chairs of design, planning and production. We try to help the designers and consult them doing design optimization. We try to integrate into the planning team and help them doing what's called design for manufacture and assembly. So designing and detailing things in a way that they can be easily and efficiently manufactured and assembled. And then that maybe tells us apart from many other planning and construction firms. We are actually talking to the fabrication and delivering fabrication data right down to the machine. So if necessary, we would provide 5-axis ISO G code directly to your CNC machine. Typically, we're jumping out a little bit beforehand, but we could if it's needed. And since all this, of course, is not a linear process, typically, there's a lot of integration, coordination involved. So half of the time we're not planning, half of the time we are talking and coordinating, sitting around tables or in front of screens nowadays, which is actually much more convenient. We've been doing this for a while and working on projects like a few timber and other grid shells and freeform projects, like you can see here, the Centre Pompidou up left by Shigeru Ban. Actually, that's only Shigeru Ban project. So there's a Centre Pompidou in Metz in France up left, and there's the Nine Bridges Golf Club in South Korea on the top right. La Scène Musicale in Paris, lower left. And last but not least, the headquarters of Swatch in Biel in Switzerland that were opened a bit more than a year ago now. We're doing facades. You see Peek Kloppenburg in Cologne, top left. You see the Kilden concert house in Norway, the Hungerburg funicular stations by Zaha Hadid on the lower left-hand side, and again Swatch, which is not only a timber grid shell, but actually also a fully functional office facade. I'll show that in detail later on. We're doing interior structures. On the top left is pavilions in the Oslo airport in Norway. Top right is the foyer of a bank in Munich, the Hypovereinsbank. Lower left is Hermès in Paris, luxury store. And on the lower right-hand side, that's actually an indoor playground at Volkswagen in Wolfsburg, which we did a couple of years ago with Hess. And now something is stuck here. And if we're lucky, we're doing event and art projects also. The top left is Eddy the skier, the mascot of the FIS World Cup in San Moritz 4 years ago already. Top right is a sort of staircase roller coaster art project in Germany, in Düsseldorf. No, Dortmund. No, anyway. Lower left is an art piece in Zurich, 12-meter high. And the lower right is a French pavilion for the Expo 2015 in Milan. So it's quite a number of projects of very, very different scope that have assembled over the past 15 years or so. Actually, 100% of them are digital, so there's always digital fabrication somewhere in there. All of them are prefabricated off-site. 80% are timber, which is something that sort of happened. It was never planned in the beginning, but it turned out that timber is actually a nice material to work with. I'll come to that. And 99%, more or less, are curvy and crazy and freeform. There's a few orthogonal and straight projects in the recent years. One of them is the lower right-hand corner. You can see that there. So why this? 100% digital, as I say, this is coming from us perceiving a gap between digital design and digital fabrication. We're doing 100% digital parametric planning because we're lazy, but we're smart. So models like the one on the right-hand side, you actually do not want to model by hand. You want to program them in one way or the other, be that in visual programming languages like Grasshopper that you can see on the left-hand side, be that in scripting languages like Python or other possibilities of actually exploiting my first job that I learned. I actually have a degree in computer science and studied architecture only on the side to exactly solve the problem of not being forced to press the same button 10 times in a row, 100 times every day, but writing a little script, a program that would do the job for us. We're doing 100% digital prefabrication because the idea is that we want to get complexity away from the building site. Building sites are cold, as you can see on the right-hand side, and wet and dirty. People like to work in t-shirts rather than in thick jackets. So what we try is that we try to put the complexity into the building parts and pre-assemble things, prefabricate things, and basically work as little as possible, or to make people work as little as possible in cold and crazy surroundings there, but rather in nicely conditioned factory halls. Why 80% timber? As I said, it was never intended. Design to production was sort of founded as material agnostic. We were just keen on playing with digital fabrication machines, but it quickly turned out that timber is actually the perfect material for what we had in mind, because timber already then, but now even more, is already digital. And what we're trying to do is mass customized industrial production. So we need fabrication machines who actually don't care if they're fabricating 1,000 different or 1,000 similar parts. And that's just fantastic when the machinery is already there in many of the carpentries here in Switzerland, but also all over Europe and now also all over the world. There is digital joinery machines that you can control with your data to do crazy curvy things. Fantastic. The second thing is timber is already prefab. Timber has been prefab for the past couple of thousand years. Carpenters have basically done the detailing on the floor and then hoisted up the beams into the roof in cathedrals already. And still the idea of prefabrication is ingrained in the brains of master carpenters. And this is really helpful when talking about how to do things. So what you can see here is a roof element for the golf club I showed beforehand. It's got a footprint of 9 by 9 meters, which would be the size of a nice little single family house here in Switzerland. And it's craned into place with only 2 millimeters of gaps around them to be placed on 4 columns in the corners. And to do this and to be able to plan this and actually then execute this, you need people with the right mindset, and carpenters seem to be just perfect for that. And timber is coming around the bend, so timber is just perfect since you can easily machine it subtractively on CNC machines. It's just perfect for building around curves, which we have proven quite a few times. Easier than steel. Yeah, you can bend it, but you have to deal with tolerances there. But as opposed to steel, you then can just shave off the last few millimeters to get the perfect shape in the end, and you can do all the detailing directly in the material on the machine, which is just great if you want to do those crazy structures there. But the question, of course, then arises, why are you actually only doing those crazy projects? And that also has 2 reasons. One reason is because we can, and it's great fun, and it's a new challenge every time Shigeru Ban comes along and basically just challenges us a little bit more than the last time. The second reason is actually those crazy curvy freeform things are just the low-hanging fruit. We're doing those crazy projects because we are hardly ever allowed to do any normal standard orthogonal projects. Because the aim is actually getting digital revolution and AEC going. And if you try that on a standard project, there's always someone who tells you that it's done differently. It's been done the past 100 years. No, we can't change it. And this is different on curvy structures because there everybody's on the tips of their toes from the beginning. So there's a completely different setting out point for starting a discussion. But as you can see in the lower right-hand corner, slowly but surely, we are also actually getting some sort of change started in the regular business also. This is partly what I'll be talking about. Because I think now is the time for digital timber. Everybody's talking about BIM and VDC. So digital planning is, after 20 years when I got in contact with building information models the first time, when I was still at university in Munich, BIM is actually finally taking off substantially. Everybody's talking about industrialized building and prefabrication and lean production and proper quality management and mass customization. And we have timber as a sustainable material, which is already digital and which is already prefabricated. So actually we are in the center of the perfect storm, I think. And we should exploit this. I think we should really take this opportunity and try to sort of combine those 3 things together and see what we can do in the middle there. So the question is, what can we do? And I'll show you 2 projects, one crazy curvy one and one straight one. And after that, I'll dive a little bit into the challenges we have been facing in those projects over the years. The first project I've already shown a bit is the headquarters for Swatch in Biel, so the watchmaker that you probably know. We've been working on that between 2013 and 2019. It's designed by Shigeru Ban architects in their Paris office. Local architect was Itten Brechbühl here in Switzerland. And I'll come to all the others involved a bit later. We were lucky to get into this project rather early. So in many of the projects we've been working on, we are entering on the side of the fabricator rather late, after tender, basically. This is one of the very few large-scale freeform projects that we had a chance to already work pre-tender alongside the architects and the planning team, and on behalf of the client. The project is about 240 meters long, is a timber grid shell with a span of 34 meters at the widest point. Sorry, up to 28 meters high. There's actually like a big question mark going around the corner, and then taking off, going across the street and resting the head of the dragon on the other side of the road, which is the Omega 2 building, which is a museum of the whole compound. So there's a couple of buildings, actually 3 new buildings by Shigeru Ban. Omega 1 is to the left-hand side out of the picture, and a few more buildings by Swatch and Omega, which is basically the same company. It's an 11,000 square meter timber grid shell, as you can see there on the left-hand side under construction, made and assembled from a bit more than 4,500 digitally prefabricated glue-lam timber segments. And on the right-hand side, you see 2 of the more complex ones. There's a few balconies in the structure where the curves get really tight. So you can see there's prefabricated timber elements up to 13-meter length to be transported on a standard truck in Europe. Completely detailed with everything you need, bolt holes, slotted plates, and so on and so forth. Prefabricated at Blume Lehmann's factory in the eastern part of Switzerland, and 3 other fabricators that worked sort of as subcontractors of Blume Lehmann there in Germany, Switzerland, and France. And on top of the timber grid shell, there's a fully functional office facade with 2,800 individual facade elements. So every square of the grid shell is filled with 1 facade element. And there's different types. There's ETFE and glass and solid elements with and without photovoltaics on top of it. Altogether about another 65,000 prefabricated parts that were pre-assembled into those elements that you can see on the right-hand side. Just to pick one out, that would be a glass element. So there's a curved timber frame, 5-axis milled from cross-laminated wood. And on top of it is a single curved glass panel that is cold bent onto the shape of the frame, actually. Then a shading panel that has a shading membrane that can be electrically closed and opened. And underneath the timber frame, there's a bit of aluminum profiles and a 3-layer glass panel for the insulation, together with an access hatch so that you can reach the mechanics of the shading panel there. We had 470 elements of this type, and they're all individual and unique, so they have to fit the curvature of the facade. On the right-hand side, you can see the pre-assembled frame made from 4 timber pieces, and then the rest of the element is actually put on top and bottom of that. We have quite a bit of MEP in the structure. So we have 20 kilometers of pipes and trays and about 1,000 heating and cooling panels with little lights in the center. You can see a curved sprinkler pipe that's following the beam there. And on the left-hand side, there's air pipes for the ETFE elements. There's the electronics for the PV panels on top and a few other things. that need to be crisscrossing through the structure. As I said, you don't want to do this by hand. So there's a fully parametric detailing in a digital model going on for all those about 75,000 individual parts that had to be planned and prefabricated and then put together. Here you see actually the fabrication model, the detailed fabrication model of a part of the timber grid shell. And what you can see is that there's 4 layers of beams running in 2 directions. So we have crossings where the beams meet each other, where we have lap joints, so that you get the impression of continuous beams there. And that was actually one of the important parts in there. I'll come to that later. We did the plan. We had the chance of doing the planning, both pre-tender and post-tender for the structure and the facade. And nobody's perfect, but almost. So there were a few mistakes in there. We had about 75,000 parts. Almost all of them came out correct. So we had problems with 93 parts that we found in the pre-assembly in the factory halls that were wrong, 4 stupid mistakes that we made. I personally am responsible for, I think, 60 of them. And we managed that only 11 parts would be found on site. So there was actually only 11 parts that had to be returned from the construction site and reworked. So we are ending up with about 0.14% of error rate, which is not perfect, but I'm actually quite proud of that in the end. This is how the thing looks from the inside. So as you can see, it's office spaces going over 4 stories. So there's a concrete structure actually on the inside. The grid shell is only the hull around it. And here you can see 3 of the 4 stories actually going down towards the end of the dragon. And this is what the front end looks like. So it's actually a really nice space to work there, I think. I've only visited, but it seems to be really nice and productive in there. And the client is very happy. What you can see there is also the different types of facade elements. So there's the opaque element with the cooling panel on the inside and the light. There's the translucent ETFE panels. And then there's the glass elements that look a bit like old-fashioned Polaroid images because they have this thick white frame on one side, which holds the shading panel inside that can be open and closed. I already told you the design architect is Shigeru Ban, local architect Itten Brechbühl, facade engineering by Leicht, timber engineering by our friends at SJB Kempter Fitze and the MAP by Gruner and Herzog & Kull. We had the pleasure to be working with the contractors for the timber structure, Blumer Lehmann. The facade was done by Roschmann in Germany. The curved sprinkler pipes were in the end done by Oeschger. There's those 1,000 cooling panels, which are, of course, also all individual by KST. And then we worked a bit on the interior with the Dunig and Rütlisberger also. So it kept us busy for 6 years there, but it was actually pretty successful in every aspect because at this scale, we could prove for the first time that we could deal with prefabrication projects in this depth over this length of time in a process. The other project I'm actually quickly going to show is our first venture into the realm of the right angle. It's a building called the Crocodile in Winterthur, close by Zurich, here in Switzerland. It's an apartment building between 6 and 8 stories high around the courtyard. And for us, it was sort of a pilot project together with Implenia, the client. It's sort of a CLT skeleton structure. So it's got CLT floors and columns and beams and fully installed wall elements in between. And those include windows, ventilation, electrical installation, and so on. They basically come finished out of the factory hall, except for some of the facade panels which had been installed afterwards. As you can see, there's hardly any wall left, which made it really complicated to get those things going. There's a lot of windows of very large scale. There's integrated columns that you can see on the right-hand side that are coming with the facade element on site. The actual building went quite smooth. The planning was a bit problematic in some parts because we were again entering rather late into the project and had to deal with the sort of BIM process that had happened beforehand. And for us, there was a pilot project, if you like, where we tried to get from a BIM planning process in IFC via Rhino and CAD work in a parametric workflow to fabrication data. So in the end, the fabricator in Plenia ended up with a detailed CAD work model that he could then go into fabrication. The parts were digitally fabricated. The assembly was completely manual. So we had CNC cut parts, and you can see there's quite a bit of detailing also going on, especially for the electrical installations. And then were placed on site. That was a bit quicker on our side as a Swatch. So we had about 18 months of total work on this project. It was finished last year and is open and inhabited by now. The architects are here from Zurich, Kilger Popp and Baumberger Stegmeier. Timber engineering was done by TimberTech, the MEP and general contractor, and basically also the timber fabricator was in Plenia, a construction firm here in Switzerland. You probably know them. So what we think after those projects, and those are sort of the latest two biggest ones that we've did, is that timber really is in the pole position when it comes to changing the building industry. It's digital prefabricated, it's a sustainable material, which is definitely becoming more important. And if we cannot really change the building industry and make it green, we can actually forget about all the rest, I would say. And it's already digital, mass customized, lean, offsite and prefab. And from our perspective, it could actually turn building into a real industry, because up to now, the bigger part of building is actually not really industrial, it's manual. It's craftsmanship actually. And to turn that into something that has controlled processes and controlled quality is something that still needs to be done. And timber could provide the means of actually turning building into an industry. But it's not that easy. So there's a few challenges that we've met over the years. And let me show you some of them. One of them is that actually current BIM process do not really deliver the information that's needed. The process is more like model, dump, repeat. I found this little diagram in the book by Bormann et al., German professor here at TU Munich. And it shows the project over time through 4 stages: design, tender, execution, operation, and it shows sort of the amount of knowledge that's in the project. So in black, there's the total project knowledge, which is going up from the start, rather steep in the beginning, of course, and then gradually gets flatter and flatter, which is quite normal. More people are involved and know more about the process. The digital information that is actually available looks different, because as of now, after every stage, we're more or less throwing away the bigger part of it. And you all know that. Everybody who's done projects knows that you develop a lot of BIM models and projects and data. And then you throw it over the fence into the next stage, and then someone's picking it up, looking at it, and throws it away. Typically, the timber contractors get whatever IFC models coming out of a BIM process, look at it, and then they start rebuilding the whole thing in CAD work or CIMA or D3 or HSB cut or whatever they're using to come up with fabrication models in the end. And of course, that's not really productive and efficient. The problem is that at every of those points of transition, there seems to be way too much information and way too little quality. Last week, I got in a schematic design stage, I got a BIM model with 1.6 gigabytes modeled down to single shingles on the roof. But it was impossible to actually find the reference surface for the curvy roof in there. Yeah? And that also comes, we think, from unclear objectives. So what we're seeing is sort of shotgun models, where someone is basically shooting into the forest and trying to hit a deer there, but mainly it's just trees, because no one knows what the fabricator really needs at the end of a planning process to come up with fabrication data for a building. And an even bigger problem is that BIM mostly stops at the end of the tender process, and then is starting again in the operation stage, where some poor facility management operator is then waiting for an as-built model. And in the execution stage, there's also a lot of data, but it's not continuous. Right? And just to be very clear about that, this discussion is not about blaming IFC and BIM for anything. I think it's not a format problem. I think it's a content problem. So it's not about the wheelbarrow that's used to transport information from one side to the other, which is IFC. It's really about what you put into the box. So when we look at Swatch, and we know that we are going to CNC fabricate building parts at the end on a machine that typically works within a tolerance of 0.5 millimeter, someone would need to translate this into imperial dimensions, I'm afraid. I'm metric here. How do you get from a competition model that you can see on the left-hand side in the rendering to fabrication data that is precise down to less than 1 millimeter on the right-hand side in one go, in one model with continuous data? How do you do that? And that is one of the conundrums in this whole BIM to fabrication discussion that is not really led at the moment. So who's discussing those issues at the moment? How are they resolved? Another discussion that's not really resolved at the moment is that prefabrication actually means product development. Yeah? We are designing parts that need to be prefabricated offsite and brought on site and then put together and fit precisely. And this is sort of the two role models that we have. One, ironically, is Swatch and has been way before we were involved in the Swatch project, because Swatch managed to save the Swiss watch industry by designing this Swatch watch that you can see there on the left-hand side. And the main trick there is that it reduced the number of parts that are needed to have a working watch from about 100 to only 51. All the remaining parts that competitors had to fiddle together to create a working watch are integrated into the plastic casing that you can see here, which Swatch invented, if you like, in the use of the watch industry. So it's about designing smart parts, basically, and integrating functions into parts, integrating complexity into parts, and taking it out of the construction or the assembly side. And the other role model is this shelf that you probably know because it's been fabricated in Sweden for the past almost 50 years. And it still looks the same as it did on day one. Changes colors once in a while, but the principle is still the same and the exterior dimensions also. But if you have happened to put together a few of those shelves over the past 50 years, you will realize that the detailing has changed dramatically from the first versions to the currently available thing there. So IKEA put quite a bit of intelligence into redesigning the joints in this shelf again and again and again, so that stupid people like you and me can put this thing together without having to call the hotline in Sweden and shout at people that the design is shitty and things don't fit together. Yeah? One simple trick, for example, was to have different drilling diameters for the dowels and the steel parts, putting the things together that you can see sticking out there. So customers were not able to put the wrong part into the wrong hole anymore, because it either would not fit in or fall out. And this is what we're trying to do in basically all of our projects on a larger scale. The problem with building planning still is that most of it follows what we call this waterfall process. So we have different stages of the building over time from left to right, and we have different subjects that we need to look into from the very first idea in schematic design or competition, where we have a context, and then very late fabrication, assembly, and operation and maintenance. And typically what we do is that we start caring about fabrication and assembly way down the process, sometimes during the coordination and detailing stage, but no earlier. Yeah? And the question now is, how should that work in a prefabricated project where you need to put things together? If you design something that you cannot put together in the end, you can as well stop at the first stage. And the other thing is, and this is also true for BIM projects, is that we have different types of models at every stage, and we replace the more detail. We replace one model with the next detailed version and throw the old one away. Yeah, this is what we've seen in the beginning, where we have a lot of information that's basically kicked out of the process and replaced and rebuilt somewhere. And we think that is not sustainable, what we're doing here. And if people show you this diagram that you've probably also seen, yeah, that BIM is about front loading. And basically, if you look at the effort in the project, most of it is happening in CD stage, where the cost of design changes is already starting to go through the roof like a Corona curve. And the effect of design changes is already pretty low and going towards zero to the later end of the process. So what McLeamy, who hijacked this diagram, told us is that it would be great, yeah, to do things earlier and have more effort earlier on. But the question now is, what is actually happening underneath those two camelbacks there? Yeah? Is it the same content, just moved forward in time? Do we do the same thing but earlier? Which would actually only result in us being stuck in the same shit just half a year earlier than we used to. So this can't be the solution. Yeah, we have to discuss what's underneath those two heaps there and what we need to change in the process. Or to put it in the words of Thorsten Dirks, who is a CEO of a Telefonica, who is a mobile communication provider here in Europe. In an interview 5 years ago, this guy said, when you digitalize a shitty process, what you get is a shitty digitalized process. And that is absolutely true, both in telecommunication as it is in AEC. And we really need to discuss what we change about the process, not about the tools that we are using to digitalize a process that's not working. From our point of view, the bottleneck is upstream. So the traditional planning processes, they do not deliver, and they probably delivered quite well for things that were built on site, but they are delivering less and less for projects that are prefabricated offsite in a completely different environment. So what we're trying to change there, what we tried and successfully did in the Swatch project, is we took the render model in the beginning, as you like, and we looked at it, and we knew that we would have to end up on the right-hand side with those prefabricated beams. And we tried to, very early when we entered the project in September 2013, the opening, just to remind you again, was pretty much exactly 6 years later in October 2019. And that's something that might come as a surprise, but it's still true in many of the projects. The first thing we did is that we sorted out the grids and the levels that were there, yeah? Just to make sure that all those radial axes would really meet in one point down there, within production quality. And if I say production quality, you now know what I mean. We're talking about less than a millimeter. Typically, what you get is you get whatever grid you have, and the axes are roughly plus minus a few millimeters there where they should, because everybody knows that the model is going to be remodeled anyways. What we wanted is that we do this once and forever and never touch it again. So the last change to the grid and the levels was done in October 2013. And then we defined the overall shape of the building, which is a reference surface defined as a digital NURB surface. And the last change on the surface was done in April 2014. So we had half a year, more or less, a bit of back and forth of defining the surface so that everything would fit underneath and the curvature was right and it was continuous enough to be fabricated in the end. And the beam axes that are crisscrossing over the surface were already defined also in parallel. And the very last change, a small thing about one of the balconies, was done in February 2015, which was a bit more than 18 months before production on the beam started, which took about a year. Yeah. So we had a production quality model at design freeze, which didn't contain very much. It actually really just contained the grids, the surface, and the axes, and not any detailing and nothing else. But we were pretty sure that we could do all the engineering and all the coordination that was necessary on the project on the final thing. And that meant that we could use this input during the process to parametrically detail down all 4,600 beam segments to include everything, and also 140,000 screws and bolts and dowels in there. This is a bit the freak show, as we call it, of the timber elements in there around one of the balconies. You can see that there. And they have quite a bit of cutting and drilling going on every of those pieces. Yeah, you've seen this already. So this is basically showing all 4 beam layers in the model. And I wanted to come back to this cutouts at the crossings you see there. That's basically typical timber connection, a half-lap joint. So every roughly 2 meters, we have this half-lap joint structure. And half-lap joint is well known in the timber community, and it's got one problem. It's got a very distinctive assembly direction. So if you want to engage one part of a half-lap joint into the other, this really only works in one direction. And the one direction is perpendicular to both the axes. And as you can see on the right-hand side, what we have is we have rather big timber beams there. They have a cross-section of 220 millimeters by fully assembled 900 millimeters. That means they're stiff. They have up to, in this case, 6 half-lap joints that have to be engaged at the same time because they're all on the same beam, but they're all pointing into different directions, which means you cannot really do this. So already early on in 2015, we basically knew that we have to solve this problem, and we designed what we call the skewed lap joint that's missing a few corners there. That can be engaged slightly from the side at an angle. And since we knew the structure already and we knew every single one of the 3,000 nodes in the structure, we could measure what the maximum deviation angle would be in there and design this joint perfectly fitting for the structure there. And this is actually what happened in the end. The problem is that all those crossings are not orthogonal. So they come at all angles between 90 degrees and down to 15 degrees, actually. And all the beams are curved. So we needed to come up with a parametric version of this joint. There would be then cut out of the beams here. On the left-hand side, you can see 2 half beams put on top of each other, just for looking if it's okay. And on the right-hand side, it's the fully assembled thing for testing. And it was quite a discussion that we had with the designers, with the architect, Scheurer, who, of course, in the beginning wanted to have those corners closed and thought that that was a bug. And in the end, we managed to convince him that it's actually a feature and looks good and makes sort of the structure readable. So you can see which beams actually going through the hole and which ones building the hole around it. And they liked it quite a bit in the end. What we also have in this project is those 2,800 facade elements, and they have 10 different types. They come in different flavors of solid, ETFE, glass, photovoltaics, operable, and so on and so forth. So already in the reference model at the very beginning, we could define for every facade element, we could define the type without the geometry. It's really just type. And what we also could do is we could already define a naming system for the whole thing, which was essential for communicating in the planning team. And since there is no perspective that you would see all facade elements at the same time, due to the geometry of the project, we came up with a little trick. But first, this worked until the very end. So you have every single facade profile and facade element, and the whole structure is basically named after this numbering system there. And that worked from 2013 until 2019, until the last screw, which made it really important and really easy to find positions for parts in there. But coming back to sort of the problem of not seeing all the elements, what we did is we built sort of two digital models. We built a 3D model and we built a 2D model also that we called the flat grid. So you have basically the fur of the bear flat on the floor with all 2,800 facade elements encoded in different colors and with the edges of the floors and with the numbering system, and also with markings for which one would have a cooling panel underneath and which wouldn't. And that served as the central thing to coordinate between all different trades and planners in the planning stage. So you can sit around the table and move around those types of elements and then basically reflect that back up in the 3D model automatically. And that also worked for the installation coordination. So the main coordination of the whole thing was done in 2D. You have pipes for sprinklers, air, heating and cooling, and electricity there. And since the different facade elements needed to be accessed with different media, we also had to make sure that everything was coming out at the right point. And that would also then be automatically put up back into 3D because it was a very systematic approach that comes from the timber side of things. In the beginning, we thought we could have an installation layer in the facade. So you see the timber structure in pink and the facade elements in blue, and in between this installation layer in yellow. It turned out to be too high, eating too much floor space and also not looking good. So it was decided to basically put everything together, and you have now the facade elements, the timber structure, and the installations all in one layer, if you like, crisscrossing, which means you have 4 different layers of installations in the structure for electrical, heating, cooling, air, and sprinklers going through the nodes and leaving enough fibers running through the node to ensure the structural integrity of the thing. So what are we actually changing in the process in Swatch here? This is sort of the process that we're trying to follow. And the difference is, A, we're trying to be agile. That means we're drilling deep at every stage from the start, but we're not staying down there and trying to sort of solve all the detailing problems in the beginning, but we try to resurface according to the stage that we're in, looking at all the topics that we need to talk about and put the results in a rather abstract model at the very top. So you've seen this reference model that would basically only contain the design surface and the beam axis and a little placeholder for every joint in there. The second thing is that we're not throwing away models after every stage, but we stack them on top of each other. So there is a context model that defines everything that we cannot change because it's around the project. There's a reference model that basically defines the overall geometry that is defined and is hopefully untouched until the end of the project once it's defined. And then there's more models until we end up with production data at stage 4 and an as-built model later on. So we're basically building a stack of models in a multi-scalar way. So we have different scales, different abstraction levels of the building in our model stack at the same time. And that is really essential for being parametric and a third point, because we can use the abstract model to create the detailed model. So we're using the model as an input to create the next level of model. And the good thing is we can do this repeatedly because we're not throwing away the old model, we're keeping it. So if it turns out that someone has made a mistake, we can change the parametrics, the rules, and can regenerate the next detailed level there at the flick of a button and not remodel everything by hand. And that is basically the idea behind the process and the modeling. And the model is very important because we think that models actually are about interfaces in the building industry. Everything that we do in coordination is we're talking about the fences between the gardens. So we need to define those interfaces in the models and not the building part. And what we handed out for tender of the Swatch project was a model that had the beam volumes without any detailing and the facade elements without any detailing, but a clearly defined interface between the two. Because from then on, we knew we would have two different contractors building the timber structure and the facade elements. And they knew where their gardens would stop. So we could tell the facade guys, hey, as long as you stay within those colored volumes there, everything's fine, as long as you fulfill the specs. But as soon as you try to stick your finger out of this model, of this volume, then the timber guys are coming probably with the chainsaw. So rather discuss this before you do it. And that actually worked quite well until the very end. Also for the MEP that was included there. Yeah? So models need to define joints, not building parts. Interestingly, it's really hard in BIM models to talk about connections and joints. They always only talk about the building elements, whereas mainly what we need to come up with fabrication data in the end is the joints and all the screws and bolts in there. So what we have is we have models that have the joints as their own objects in the model that then define the parts in the end. And that's sort of what we learned after doing this for 15 years. That is actually pretty strange. No one else is doing it. Yeah? There's no chance of really defining the joints as objects in an IFC model, for example. So for some reason, we've done some things right, but completely different from anyone else. And what we're trying to do now is basically put that down from the Formula One projects that we've been working with to the street and see what we can do on more standard projects there. So what we're doing is we're planning. That is sort of the core of our business. We're also providing software in terms of planning tools and CAD/CAM plugins and web apps and database applications for BIM software and so on and so forth. And we're trying to sort of get the production knowledge forward in the process and consult planning teams about BIM and DFMA and how they integrate timber construction, digital fabrication early on, because if it's not designed for timber, it's not going to work with timber in the end. Since we have probably a rather specialist knowledge, we teamed up with a few allies there recently, which is SJB, the timber engineers that I've already talked about, that we've been working together in quite a few projects. Knippers Helwig, who are civil engineers and facade engineers from Germany, that we are working on 2 projects at the moment, and Ignis, who are doing fire design consulting services, especially also for timber, for fire protection, to try to integrate all the knowledge that we have in an open space, in an open alliance. So if you call any one of us, you basically get the whole team. Feel free to give us a shout if you have troubles in your timber projects and need some consultancy. I'm happy to take your questions. It was a bit longer than I expected, but I hope you still have time I have half a bottle of beer standing there on the side, so I shall be happy to take all your questions. And if you don't have them now, please feel free to send me an email. You see the email address over there. Thank you very much.
Thank you, Fabian. I was just looking at your homepage on your website, and it states, "We master complexity." How a perfect, concise, and appropriate. And now with this video, when people want an explanation, thank you for having that. You can share it with people to show just how far you take things. Yeah, I have a couple of questions came in. If you could answer them, thank you for that. Stefan Schneider asked, "We see a similar trend here in North America. Despite better software interfaces, we end up using maybe 1% of BIM models for fabrication. Most challenges are data accuracy and impossible details. This is forcing us to redo 3D models in CAD work format. In our case, we would like to use BIM models more and add fabrication info into it rather than redo the entire model. How do you think this could be resolved? How are leading companies in Europe addressing that challenge?"
Last questions, they don't. We were just starting the discussion, I think, there, because this is really the core of what I was sort of talking about. And I think the discussion should be leading into the direction that only small models are good models. Yeah. If you don't know what you're doing, then just leave it out of the model and deliver what you know, because the rest will be filled in by the next one. What we see at the moment is that there's what I call shotgun models, where there's tons of information in there, which you cannot decide anymore which information is serious and which one is just there because someone knew how to deal with Grasshopper, Dynamo, whatever, and just created 15,000 shingles on a roof without ever knowing how they will be looking in the end. So I think the discussion definitely needs to start about how do we get rid of information in BIM models. And our role often is the sort of, I call it a digital Marie Kondo in BIM projects. It comes and looks at your storage and says, listen, do you need all this? We're going to sort it out. And then if after we sorted it out, we only keep what's necessary, and then we fold it up nicely and put it on the shelf. And this is definitely what needs to happen in the BIM world also. So I'm looking forward to this discussion. Just limit the transportation space would be one thing. Yeah. The problem is that digital files transportation is too cheap for digital information. Yeah. If you were to hire a lorry to bring a BIM model from A to B, they would be considerably smaller.
That's great. It's just easy to dump data but poorly unstructured data. All right, thank you for that. Here's another question. Shamnat Tajuddin, what is your opinion on applying visual parametric modeling in the design of a particular building components? My research work looks into a glulam-based post and beam building system from a Swedish company, and the main challenging component is the connectors, as the variants are increasing after each project.
Yeah. Maybe two answers. One, we're using visual parametric modeling, but only in very early stages of the project, because pretty quickly it gets too complex, or the models get too complex for visual tools like Dynamo or Grasshopper. You have to just be aware that a project like Swatch is taking 6 years from start to end. So at some point you need to sort of drop a model and freeze it and fix it, and then in the next stage pick it up from there and then do things with it again. So there's no way that the whole thing would be a dynamic model from start to end. That's one thing. The other thing is for 75,000 parts on fabrication level detailing, you cannot do this in one go. So you have to divide that over a number of different models and a number of different steps, because also the information comes in gradually. So what we do is that we basically use a 3D model as a database, and then we pick geometry up. We pick objects out of the model. We have a script, a parametric script that does something with this object and then drops it back into the model. And so we have sort of a consistent state every time we do something. And then just wait until we get more information about the screws and bolts and stuff, and then we take the next step. And the other answer, and I'll try to make it short, is try to get rid of complexity. As soon as you have 3,000 joints and 4,000 different types, you've made something wrong. You need 3,000 joint and you need exactly one parametric type that works on all the joints. Maybe 2 or 3, so to sort of post the corners of the solution space. And that is what's making it so difficult and so important to come in early in the project, because once an engineer has come up with 15 different solutions for the same problem, it's very hard to get rid of them again. So you have to be there early and discuss with them if they really need that one special case that they're trying to do that.
Okay, read the next one. Yeah, Florian Schmid says, thank you for sharing the unique and inspiring projects. Given the complexity of the projects, I imagine you allocated a lot of knowledge around design for production and assembly. Have you ever thought about using your knowledge in a kit of parts for less unique but more scalable building solutions? Why or why not?
Yes, we did that. Yes, it's really hard, because if you come up with a kit of parts, that would mean that you use it more often. Shigeru Ban likes it to be unique. That's one thing. And all those other sort of Formula One architects also. But this is actually what we're trying to do with those more orthogonal projects, is really to come up with ideas of how do we get this out of this Rolls-Royce Formula One corner and onto the street for everyone. It's just so that for coming up with a kit of parts, you don't only need the idea, you also need someone who's actually then fabricating 15 or 20 or 30 houses with those parts, and is willing to do an investment into product development in the first stage. Yeah. It would be a pleasure to discuss those things with someone who wants to do this, but it's a bit bigger than we can actually come up with an investment for. So we need someone who wants to do it and needs know-how, and then you have my email.
Maybe there are a few of those people in the US.
I shall be glad. It's traveling is not an issue anymore now. So.
Yeah, we certainly have the housing demand, and it's such early days here for building those building systems. Yeah, the demand is certainly there. Next question is from John Boyce, a builder up in Canada. Can you comment on the tender process for public projects that presently throw the low bids into a project at a very late stage and hope for the best?
Stupid idea. Right. I need to say concise. More.
Yeah. No, actually,
no. I mean, this is. I know how this is working. I mean, I'm in Europe. I'm from Germany originally. There's a lot of things going into this direction, which is not going for the best. If projects become more complex, then you're definitely lost. This is working on standard off-the-shelf projects, maybe, if at all. But it's certainly not working on a project of a certain complexity, and certainly it's becoming much more difficult if you're talking prefabrication. So I think it's a stupid idea, but luckily I feel I'm not alone anymore. And there is a lot of discussion about different procurement models also here in Europe, and Germany and Switzerland. We're working on. Swatch, of course, was a private project, so they could choose whatever they wanted. But we're also working on public projects in Germany now, where they are managing to somehow tweak the overall planning and tender process into a direction that makes much more sense for more complex structures that are prefabricated. But it's a hard discussion.
It's a really hard discussion. Some of the other presenters have also addressed it. And I think we're seeing in the States, one of the things in the mass timber market is people are trying to price projects, often not factoring in the services you're providing. That mastering that complexity, too often it's just pricing materials. And I think a lot of the market doesn't know what those costs are or what the benefits are of doing that upfront. And even in the Swatch project you reference, having things defined in 2014, 15, then locking in the design. So you could master all that complexity as opposed to continually changing the design up to and even during construction, which is it's pretty common here.
I mean, this is also teamwork. I mean, we would be lost in projects like Swatch without having sort of the sparring partners on the other side of the table, like SJB and knowledgeable facade engineers, who are either already convinced or we are able to convince them about having a very systematic approach about doing projects like this. And I think that's the key, because I mean, all the discussion about parametrics is not working if you basically end up with only special cases everywhere. Because the nodes are all different in geometry, but they're all following the same rule. And as long as you can manage to do that and come up with design and fabrication principles that reflect that, it's easy to pull off our parametric trick there. And if we can't do that anymore, we're just lost in manual detailing again, which is not sustainable. So it's a lot about the mode of thinking behind those projects that is very important. And that, unfortunately, if you look at things like the housing project I showed, the interesting thing is that on our side, basically the same amount of man hours went into Swatch, the whole thing over 6 years, as it went into the crocodile over 18 months. Because all those right angles look easy, but you are having a lot of coordination issues in there. And if you have an architect and a planning team that you cannot influence because you are coming late into the project, they have already messed up this thing considerably sometimes, especially if they're coming from a non-timber background and suddenly have to design an 8-story timber building. Then you can only hope for having a timber engineer in the planning team from the beginning that's doing this Marie Kondo job from the very first second and sort of whip them into shape every other week to be systematic and to be timber friendly, if you like. If that's not happening, then you end up, as we did in this project, with I think 92 different window details for 250 apartments.
Well, one of the reasons I organized this conference is for the kind of thinking you're expressing in that informal alliance. How do we get knowledge and appreciation for that cooperation to come to other markets? For example, to the US. So we're not reinventing the wheel. So we're making mass timber industry more successful and mass timber buildings more affordable. We're kind of behind thus far in our smaller markets. So it'd be great if we could bring that over, and that would be more opportunities for you as well.
Yeah. I mean, it might look very glitzy here from the other side of the pond, but as I try to explain, there's still a lot of challenges that we're also facing here. And I can only urge you to not fall into the same traps. But I mean, the important thing is, and this is what consulting is all about, is to find someone who's already had the troubles and got a bloody nose in 1 or 2 occasions to learn from. And I shall be happy to present you with a few terrible mistakes that have happened also on our side to avoid them in the future. So don't be afraid of being behind. Think of it as sort of being warned about what has happened already.
Well, I think they're challenges, but they're also massive opportunities.
Yeah.
So yeah, and I think there will be a lot of those for people like you who have already been working on these challenges for years. Okay. I want to ask one more, just a comment actually. Stan Chow says, great presentation, Fabian. Regards from Taiwan. Perfect.
Thank you very much.
Great. And you shared your contact information on your last slide. You've been generous, giving us over an hour of your time. Look forward to actually seeing you again online, as well as at events, hopefully in Switzerland in January.
It was an absolute pleasure. Thank you very much again for the invitation. I'm looking forward to seeing the recordings of the previous presentations. I was not able to attend them because of time things and family dinners and stuff like that. But I hope that you have them all recorded and I can have a look. And I look forward to receiving emails with more questions.
Of course, I'm in my spare time, I'm learning video editing. So they're all recorded, and I do hope to get them posted in the next 24 hours, the first week's worth, trying to get that turnaround and then just make them freely available so more people can view great presenters like you. I think that kind of information should be freely available just to help the industry.
Super.
All right. Thank you for your time.
Keeping my fingers crossed, and
Okay.
hope to see you soon.
Thank you.
All right.
Thank you, everyone.
Have a nice one. Thank you, everyone.
Goodbye.